All right, hello and good morning. Let's take a look at the bell work here. Now, we did the quadratic formula Friday, and we're going to continue it today. So look up here. Now, you could try to factor this and then set your factors equal to 0. But we're going to use the quadratic equation because, quite frankly, it might not factor. In fact, I don't think it does, because 2 times 3 is 6. And 1 times 6 will add up to give you 7, but if you look at your signs, a negative and a negative is going to give you a plus and a minus. So you have to subtract. And so there's no combination here that's going to give you a 7, since you have to subtract. And when you subtract, you get 5. So the best you could do here is 5. So you can't factor it. You're forced to use the quadratic equation. Even on the ones you can factor, you can use the quadratic equation. That's the nice thing about it. What I want you to do always is to put parentheses like this. And then substitute. Well, you got to identify your A, 2, your B is -7, and your C is -3. So it's going to be negative B, and you already have a negative in the formula, but the number has a negative, so that's going to be a double negative. Minus 4 times A times C, all divided by 2 times A. Let's take a look here. This becomes a plus. That gives you 49. This becomes a plus. That's 8 times 3, that's 24. And then down here you get a 4. Now, I'm not sure that this is going to be perfect square, so let's add it up. 49 plus 24. That gives me 73. So this is going to be the square root of 73 right here. So you're going to have 7 plus the square root of 73 divided by 4. There's your plus. And then you're going to have 7 minus the square root of 73 divided by 4. Now, it's best to leave it on your calculator like this. Don't round it. So you're going to do shift, square root, and then plus 7, divide by 4, and then your final answer, I want you to round it. So I'm going to say 3.9 on that. All right, watch again. 73, shift, square root, put a negative in front of that, and then plus 7, and then divide by 4. That's going to give me a negative 0.4. And that's how you do it. Those are your two answers. Okay? And again, you want to round it when you're done, not right here. You want to use this and then round your final answer. All right, this one right here is basically the same thing as the one we just did, but you have to get it equal to 0. So what you want to do is add 10 to this, and when you add 10, you get a -3, and it becomes the same exact problem. So I'm not going to work it twice, but I just want to make sure you understand that you need to get it equal to 0 before you identify your A, B, and C. One more. Let's take a look at this one. This one you have to get it equal to 0, so that's going to become a -80. So 5x squared minus 80 is equal to 0. So your A is 5. There is no B because there's no x, so put a 0, but the C is -80. So what you're going to do is just work this out. So x equals -b, b is 0, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Okay, so this 0 just goes away right here. This becomes a plus. So there's no plus and minus here. Actually, there is. So what you're going to do is this. You're going to take your calculator. 4 times 5 is 20. Clear it out. So you're going to have 20 times 80. Press equals. And then hit shift, square root. And you get 40. And then you want to divide by 10. So you're going to get a plus and a minus 4. So your answers will be a plus 4 and a minus 4. And that's how you do that, okay? So remember this right here, ax squared plus bx plus c. The number in front of the x squared is your a, in front of the x, and this one doesn't have an x. It has an x squared, but not an x. Not the same thing. And then the c stands for your constant, and in this case, it's a negative 80. And that's how you do that. What I want you to do today is to work the back side of the worksheet from last week. Okay, so here's the back side of it, and this was worksheet B, but I want you to go ahead and change this. So put worksheet A and put 8.3. All right, so it's the back of the one we already did. All right, let's turn our attention now to geometry. Well, let's take a look at this bell work here. It's a tangent, so we know it's 90 degrees. So right here, I'm going to use a red color. It's 90 degrees to the triangle. We know this is 80. Every triangle is worth 180 by something called the triangle sum theorem. And you want to remember that name anyway. So you're going to take 180, and you're going to take 80 plus 90 plus x, and you're going to set it equal to 180. And I want to see this equation. Basically, you're just going to subtract 170, I guess it is. So 170 out of this is going to be 10 degrees. So x has to be 10 degrees, and that's how you do that. This one right here, we talked about the area of a triangle. You need to memorize that formula. And the trick here is we know the base is 8, but we don't know the height. So what you're going to do is take this triangle out right here, and you're going to split the bottom and make that a 4. You're going to put an x here. This upper angle that was 60 now becomes a 30, and you're going to either use special triangles or trig. I'm going to stand right here, so it's opposite. I'm going to use the opposite. I guess you could use hypotenuse. So I'm going to say opposite over adjacent. So I'm going to say the tangent of 30 degrees is equal to the opposite over the adjacent. Now remember, you don't want the x in the bottom, so you want to take all of this and switch them. So x is equal to 4 divided by the tangent of 30 degrees. That represents your height right there. Okay? So now let's go back to the formula. Area of a triangle equals 1/2. So you're going to divide by 2 in a minute. The whole base is 8, so you want to use 8 right there, times the height, which is 4, divided by the tan of 30, or tangent of 30. And that's it right there. So let's work it. Clear your calculator out, get it out. I'm going to press 4 divided by 30 tan, press equals, make sure you press equals, times 8, and then divide by 2. I get 27.7 square inches, and that's how you do the area of that triangle. And you need to know how to do that, okay? So all you do is drop an altitude, you split the upper angle, and you split the base. You pull the triangle out, you do some trig on it, and then you use your formula. Last thing you do is divide by 2. Make sure that when you divide this, you press equals, and that's the trick. All right, on a new sheet of paper, copy down some definitions here. A chord is a segment whose endpoints are on the circle. So let's draw a circle and then draw a chord. That would be a chord right there. So this would be chord AB. Okay? The longest chord is one that goes through the diameter, or through the center of the circle, called the diameter. So the diameter, and I want you to write this down, is the longest chord. So a chord has the endpoints on the circle, whereas a secant is a line that goes through the circle that has 2 points on the circle. And that's it. That's called a secant. Okay? And then, of course, you should know the radius. The radius is from the center. That's your radius. The diameter is the big long one, 2 of these. So your diameter would be all of that from stretching straight across. And your tangent is a line that hits the circle at one point. That's a tangent. Make sure you know that. All right, let's go on to today's work. Draw these two diagrams here. All right, question is, are those triangles congruent? Well, these are congruent because you have vertical angles here, and it's side, angle, side. So it's side, angle, side congruent. So yes, they are congruent. This one right here, these are not vertical because they're off a little bit. But this is a radius. All of these are radiuses because they go from the center to a point on the circle. So all of these are equal. All the radiuses are going to be equal. So it's going to be side, side, side. So these two triangles, this triangle and that triangle, are congruent by side, side, side. Congruency. All right, let's go on. Copy down this stuff right here and draw that diagram. Theorem says if two chords are equal, then the distance to the center of the circle are, let me read it again. If two chords are equal distant to the center of the circle, then the chords are congruent. So what this is saying is, if you have a circle and you have a chord like this and another chord like this, the only way this chord is equal to that chord is if the distance to the center of the circle, and distance is always 90 degrees. So if this distance here is equal to that distance, like 7 and 7, then this chord would be equal to that chord. And the converse is true. If the chords are congruent, then the distances are congruent. Make sure you know that. Okay? Okay, so let's move on. This one says if an arc is congruent. So if arcs are congruent, then the chords are congruent. And the converse. Let's talk about that. So if you have a circle, and let's draw two chords here. Okay? If this arc is 30 degrees, and this arc was 30 degrees, even though the diagram doesn't look right, then the chords would be equal. So if the arcs are equal, then the chords would have to be equal. If the chords are equal, then the arcs are equal. So the converse is true. All right, let's take a look at this diagram. This diagram is nothing more than a right triangle. So draw a right triangle like that. Your hypotenuse is 13. It looks like your short leg is 9. Short leg, long leg. And so you're going to do 9 squared plus x squared is equal to 13 squared. You're going to use Pythagorean's theorem. So you're basically going to subtract. So x squared is equal to 13 squared minus 9 squared. So x is going to be the square root of whatever that is. I think 13 times 13 is 169. You can check it, minus 81. So whatever that is your answer. Really not a hard problem there. All right, one more. Draw this diagram. We're going to answer these questions, and I'm going to get you started on your work. Let's take a look. Look at what's given here. AC and DF. Okay, let's see. AC is this one. So this chord is equal to this chord, given right here. That's the reason. And arc AB is 40 degrees. So this arc, AB, this little bitty arc, is 40 degrees. That would make this one 40 degrees because it's perpendicular. That would make this one 40 degrees because the chords are equal, the arcs are equal. So we got all of that here. Let's see what they want. They want DF. Let's see if we can find that. Now I'm thinking they should have given us some more information here. So DF. DF is this segment. We know this segment is equal to that segment. Let me take a quick look and see if I'm missing something from this diagram here. Okay, so DF is what they want you to find. Oh, there is a 2 right here. Okay, so I missed that. So GC was 2. So that would make this 2, that would make this 2, and that would make this 2. So DF would have to be 4. That's pretty easy. We were just missing that. FH, let me find FH. FH, where is that at? Let me look in the book and see if I missed something again. FH. H is right here. Okay. So FH, let me think now. It's 2. That's easy. And AC, where is AC? AC is the whole thing, so 2 plus 2 is 4. This is pretty easy. Arc, as long as you got all the information. Arc AC is from here all the way to here, so the arc is 40 plus 40 is 80 degrees. That's the measure. Arc DE, let me look at that one. DE is 40. We already got that one. And then the arc DF, where's that at? DF is the whole thing. That's going to be 80 degrees. That actually was pretty easy exercise. Here's your work for today, so if you get stuck, make sure you ask questions. And go back to your theorems if you need to. All right, have a good morning, and I'll see you in class.